everyone.
Good evening.
Okay, so for our class today, we're going to be talking about trends in the periodic table. So I've drawn as a sample of the periodic table. It's not the exact one, but this is just for me to explain the trends of the periodic table. But I want you guys to look at your notes that I've given yesterday. I want all of you to copy your notes, and so we're just going to go through it today. Okay, so what is a periodic trend? A periodic trend is a pattern of change in the properties of elements in the periodic table. So it increases with atomic number, and the important trends that we're going to be talking about would be atomic radii, ionic radii, ionization energy, and electronegativity. Okay, so we're going to talk about the terms. So nuclear charge. Nuclear charge is the total number of charge of the protons in the nucleus. The effective nuclear charge is the net positive charge that is experienced by the valence electrons. Okay, so net effective nuclear charge is when more electrons are added, the net effective nuclear charge decreases. This is due to the shielding effect, which leads us to our next term, which is shielding effect. Shielding effect describes the decrease in attraction between an electron and the nucleus of any atom with more than one electron shell. So the greater the number of electrons, the greater the shielding effect experienced by these valence electrons. This is because valence electrons, they repel each other, right? Yes, okay, so if electrons, they repel each other, and so once they repel each other, the shielding effect increases, and so the trends in the periodic tables are affected. Okay, so for our first trend, we're going to be talking about what? Atomic radius. Okay, atomic radius, yes. Atomic radius, it describes what? The size of the atom. Okay, so it describes the size of the atom. So across the period, we know that the atomic radius decreases. This is because when you go from left to right, the number of electrons are being added onto the same shell. And when it adds onto the same shell, the effective nuclear charge increases, and thus the atomic radius decreases. Seth, is that clear?
Yes.
Okay, so moving on, when you go down the group, atomic radius increases. It increases. This is because when you go down the group, you are adding more shells onto the atoms. Yeah? So when you add more shells, the effective nuclear charge decreases because the distance from the nucleus to the valence electrons increases. Yeah? And that causes the shielding effect. Shielding effect comes to play with more electrons that are added onto the shells, and so once the shielding effect adds onto the effective nuclear charge, it increases the size of the electrons. Yeah? So that is why electrons have a bigger size when you go down. Is that clear?
Yes.
Okay. Our next trend is ionic trend. So ionic trend, it describes the ionic radius of an ion, so the size of an ion. And so we have two types of ions. One is the what? Cation ions, and another one is the anions. So we know that cation ions are positively charged ions, and they are always smaller than their atoms, which they are formed from. This is because when, for example, sodium ion is usually bigger than sodium atom is usually bigger than sodium ion. This is because when sodium becomes an ion, one of the electrons is removed. Yeah? So there are more protons than electrons in this ion, and so it pulls all the electrons to the middle of the nucleus, and that is why it decreases the size of the cations. Yeah. So now that there are fewer electrons to be pulled towards the nucleus by the same protons, there is a stronger attraction. The nuclear effective charge increases between the nucleus and the electrons from the outer shell. Anions are negatively charged ions, and they are always larger than the atoms which they are formed from. This is because when an atom, for example, chlorine atom, this is because in the chlorine ion, when it becomes an ion, there it has one more electron onto its outer shell. And so when there's more electrons on the outer shell, there are more, when there's more electrons on the outer shell, the effective nuclear charge decreases. So once it decreases, the shielding effect comes into play, and there's weaker attraction from the nucleus to the outer shell. That is why the ion size is bigger. Is that clear?
Yes.
Okay. Moving on. Our next trend is ionization energy. So ionization energy is the energy required to remove an electron from an atom when it's in its gaseous state or gaseous form. Okay, so it reflects how tightly an electron is held by the nucleus. So as you go across the period, the ionization energy it increases. It increases across the period. This is because the electrons that are on this one shell are held tightly by the nucleus. So once it's held tightly by the nucleus, it's a bit hard for you to remove the electron from its outer shell. But as you go down the group, the ionization energy, it decreases. This is because there are more shells, so the attraction between the outer shell and the nucleus is lower, as we talked about it. And then once that happens, it is easier for you to remove an electron from its outer shell. Okay, so ionization energy, that's the first ionization energy that we talked about. There are three types of ionization energy. Ionization energy is the first energy to remove the first electron from an atom, a neutral atom. For example, this is the first ionization energy. The second ionization energy is the energy that is required to remove a second electron from the already positively charged atom. We know when the ion is positively charged, that means there is stronger attraction from the nucleus to the outer shell, and that is because of the increase of proton. So, to remove an electron from plus, the second ionization energy is higher than the first ionization energy. This is because we need, stronger energy to remove the electron from an already positively charged ion. So it's already holding onto the electrons tightly. So now we're trying to remove one electron, so it's going to be very hard to remove. So ionization energy is higher than the first ionization energy. The third ionization energy is simply the same thing, but except now we're dealing with a proton, and positively charged ion that already had lost two ions already. So when you try to get one more ion out of this, one more electron out of this ion, you need even more energy to remove it. So when you're trying to describe the types of ionization energy, the first ionization energy is less than the second ionization energy and is less than the third ionization energy. Is that clear? Yes. So which energy is the highest? The third or the first? Yes, the third energy is the highest. Okay. So for our last thing, we're going to be talking about electronegativity. So electronegativity is the measure of the strength of an atom's attraction for the shared pair of electrons. So you did know that in a body, an atom, they share an electron. They share an electron. So electronegativity is the measure of strength of an atom's attraction towards the shared pair. Okay, so across the periodic table, electronegativity also increases across the line. This is because the effective nuclear charge increases since the electrons are added to the same shell. So more electrons added to the same shell, the more attraction to the shared pair of electrons. Is that clear?
Yes.
Okay, so as a result, the electrons are held tightly by the nucleus, and because of the small size of the electrons, it requires a really high electronegativity um, to the shared electron pair. Is that clear?
Yes.
Down the group. So down the group, the electronegativity obviously decreases down the group because when you move down the group, there are more shells and yes, it's bigger, so it increases, and so there's also increase in the shielding effect. All of these factors increase the nuclear charge. Despite the nuclear, despite the nuclear increase in nuclear charge, all of these factors affect the electronegativity, and thus it decreases down the group. Okay. So for that, we are done with our trends. I believe I gave you guys a worksheet on ionization energy. Can we do that right now? Okay, thank you so much. I've seen a lot of you have answered the questions, which is good. I see a lot of you understood it. But so today, as we're going to wrap up our class, today we learned that the atomic radius is what? Decreases across the period. Yeah, this is because of the stronger pull, and then so the size of the atom decreases. The ionization energy increases across the period. This is because what?
Electrons held tight.
Yes. Thank you, Kenai. Electrons are held tightly, and so that is why ionization energy increases. Yeah? Electronegativity also increases across the period, and as we go down the group, atomic radius increases. This is because the atomic size, the electron pull from the nucleus to the valence shell, the shielding effect increases as you go down the group. That is why the atomic size increases. Is that right?
Yes.
Okay, so ionization energy also decreases, and electronegativity decreases. And you can see that these two are opposites of each other. So if one across the period it decreases, then down the group it'll increase. Yeah? And so please take note of that, because tomorrow complete your worksheet on the ionization energy, so that we can mark it tomorrow as a class. Is that clear?
Yes.
Okay, thank you so much, everyone.
Thank you, ma'am.